Here are some examples of solving trig equations. Some of them we are going to start using identities too. So cos theta equals minus 1 over root 2. Our first step is to determine where our solutions are. So since cosine is negative, it could be in our second quadrant or our third quadrant. We know that our related acute angle to this is going to be pi over 4 because of our special triangle. So that means in our quadrant 2, our first x solution is going to be pi minus our related acute angle, which is pi over 4. So then our first solution is going to be 3 pi over 4. Our second solution in quadrant 3 is going to be pi plus our related acute angle, which then gets us to 5 pi over 4. In our second example here, we've got secant theta equals 3.4 and some change. The first thing that we want to do is change this into one of our trig ratios that we know. And then I'm going to isolate cos theta by taking the reciprocal of both sides. So 1 over 3.4721 is now actually equal to cos theta. So then I can divide that on my calculator and I get a decimal of 0.2880. Now it looks like the equations that we were solving before. My cosine ratio is positive. So that means I could have solutions in the first quadrant or in the third quadrant. I need to figure out my related acute angle by taking the cosine inverse of the positive version of my right-hand side. When I do that, I get 1.2787. That represents this value right here in between my terminal arm and my nearest positive x-axis or nearest x-axis. So my first solution in quadrant 1 is that my solution is just equal to my related acute angle. So I get 1.2787. In my fourth quadrant, my second solution, I'm going to get 2 pi take away my related acute angle. And when I put that into my calculator, I have really 2 pi take away 1.2787, which gives me a decimal value of 5.0045. My next example, I have to do some rearranging first. So I'm going to isolate tan theta by moving 1 over to the right-hand side and dividing by 4. Then I'm going to figure out where my solutions are. Tan is positive, so I'm going to have a solution in the first quadrant or in the second quadrant, not the fourth quadrant. Oh, third quadrant. First and third for positive tan. So my next step is to now find my related acute angle. So I'm going to take the tan inverse of 1 over 4. That gives me a related acute angle of 0.2450, which represents this distance right here and this distance right here. When I find my solution in quadrant 1, my x is just equal to the related acute angle. So that means my first solution is 0.2450. And my third solution is equal to pi plus my related acute angle. And then I've got x squared, or x2, my second solution, is going to be 3.3866. And I'm actually going to go through and change something just so that it matches for proper form. I've been using x in my solution, but my original equation had theta in there. So I'm actually just going to go ahead and write my unknown as x, just so that it matches. But you should use the variable given to you in the question in terms of proper form. This one I'm going to just change these ones to theta down here because I think that's a little bit easier. Theta, 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 theta. And this one I will change over here to cosine of x. But that unknown should match the variable that you answer in the solution. Okay, so now that we've done those two, or those three, we're gonna do a couple more. And these ones have some more algebra and they have a couple identities in them as well. So I'm solving for theta. And what I notice right here is that now I've got multiple trig terms and they're on both sides. What I'm going to do is I'm going to move everything to one side. And then I'm going to factor out the common term. So sine theta is common between those two. So now I've got sine theta is equal to times tan theta minus 1 is equal to 0. So now I really have two equations that I can solve here. I know that sine theta could equal 0. I also know that tan theta minus 1 could equal 0. So in order for sine theta to equal 0, in between 0 and 2 pi, there are three possible values. So theta could equal 0, pi, or 2 pi. That would satisfy the equation. In order for tan theta to equal 1, I know that for tan to be positive, I could have a solution in the first quadrant or the third quadrant. I also know that to have a tan ratio of 1 goes with this special triangle, which means that my related acute angle is pi over 4, which I know is this distance here and this distance here. So theta could also equal pi over 4. That would be the solution in my first quadrant. And theta could also equal 5 pi over 4. That would be my solution in the third quadrant. So I've got 5 values total that would satisfy that equation, make the left side equal to the right. Similarly, over here, I've got tan x times cos x equals 0. So these are two functions multiplied together could equal 0. So that means that tan x could equal 0, or cosine x can equal 0. Tan x, the graph sort of looks like this, and the period of tan is actually pi. So x can equal 0, and we've got x, so we're using the right variable this time. It could equal 0, at pi, or at 2 pi. Cos x can equal 0 at pi over 2, or 3 pi over 2. So really I've got 5 solutions here. X can equal 0, pi over 2, pi, 3 pi over 2, or 2 pi. All of those values would satisfy that equation. In my next example, I've got 3 terms this side, and they all happen to be on one side of the equal sign, which is great. What I want to do is to factor. This is the same equation that I have here if I replaced sine x with a. So when I do that, I'm going to get 6a squared plus a minus 2. And then I have a tricky trinomial that I can factor by using decomposition or any other method. It would factor to 3a plus 2, 2a minus 1. But I know that a isn't really what I'm looking for. A is really sine theta. So similar to the first example, I here have 2 equations now that I have to set equal to and solve. So my first equation would be that sine theta plus 2 is equal to 0, which means that sine theta could equal minus 2 over 3, or I could have sine theta equals 1 over 2, which comes from this 2 sine theta minus 1 equals 0. So now I've got 2 equations that I need to solve. One of them is a special triangle and one of them is not. The approach is the same. So here I'm going to figure out, because sine is negative, I could have a solution in my third quadrant or my fourth quadrant. I'm going to find my related acute angle by taking the sine inverse of the positive ratio. This is going to give me my related acute angle of 0.7297, which is this distance here and this distance here. My first solution is in my third quadrant, which is pi plus my related acute angle, which gives me a value of 3.8713. And my second value is 2 pi minus my related acute angle, which is going to give me a value of 5.5535. For my second equation, I'm going to find my locations, first quadrant and second quadrant, because sine is positive. I know that this one comes from a special triangle, and so my related acute angle is pi over 6, which is this distance here and this distance here. My third theta is the solution in the first quadrant, where it is just equal to my related acute angle. And my fourth possible solution is going to be pi take away my related acute angle, which is still the fourth solution, which would give me 5 pi over 6. I will do some more, the remaining examples in a second video.